Hello, everyone. Greetings of the day. Dear authors and invited guests, welcome to Technical Session 11A. Myself, Prashi, and this session will be moderated by. On behalf of Global Knowledge Research Foundation and GR Scholastics, it is my great pleasure to welcome you to the 10th World Conference on Information Communication Systems, Software, Security and Sustainability WorldS4 2026, London, UK. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 29th to 30th of July 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for their presentations and 3 minutes for the question and answers. On the 10th minute, I will raise a gentle reminder. I repeat, on the 10th minute, I will be raising a gentle reminder. There is another request to all of our participants that you all stay connected with us till the closing remarks. If you have any queries or any updates, then you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to our chairs for the session. Our first chair is Dr. Sunway Kim. We welcome you to the session, ma'am.
Hi.
Dr. Kim is an associate professor of computer science at St. Joe's State University, United States, with over 25 years of extensive professional, academic, and research experience. Her core expertise encompasses database management systems, NoSQL data models, geospatial-based databases, and system performance evaluation. We welcome you to the session, ma'am. Would you like to address our participants before we start?
Thank you. Hi, everyone. Welcome to this technical session of WorldS4 2026. My name is Sunny Kim. I am from San Jose State University in United States. And it is my great pleasure to serve as one of the technical session chairs today. Along with my fellow session chair, Dr. Mishra, I will help facilitate the technical discussion by engaging with presenters through questions and comments. I look forward to excellent presentations and insightful discussions. Thank you.
Thank you so much, ma'am. As ma'am has already mentioned, I would like to introduce you all to our second session chair, Dr. Durgesh Kumar Mishra. Dr. Durgesh Kumar Mishra is the Vice Chancellor, Director, and Professor at the Symbiosis University of Applied Science, Indore, India. He is also a visiting faculty at IIT Indore, MP, India. He has 30 years of teaching and 15 years of research experience. He has published more than 100 papers in referred international, national journals and conferences, including IEEE, ACM conferences. We welcome you to the session, sir. Would you like to say a few words before we start our session today, sir?
Yes, thank you. Thank you, Prashi, for the introductions. And thank you, Kim, to join with me as a session chair jointly. And I think we have a presentations. Definitely, we will discuss the lot of things here during these sessions in all the 6 papers. And this, I know this is a very good platform where the researcher can share their knowledge and then can discuss with the other colleagues and other presenter as well as the session chairs. So thank you for inviting me for the 10th World Conference on the Information Communication System, Software, Security and the Sustainability in the WorldS4 2026. Thank you.
Thank you so much, sir. Thank you so much,
Thank you,
ma'am.
Kim, namaskar. Thank you.
Thank you so much. So, without any further ado, I would like to call upon our first participant with permission from ma'am and sir.
Yeah, thank you. Yes, please.
Okay. Yes, thank you so much, sir. Our first presenter for this session is Ritesh Kumar, presenting a paper on the title, A Novel Matrix-Based Two-Stage Encryption Framework for Twitter Polarity Score Security. I request you to kindly take over with your presentation, sir. Sir Ritesh Kumar. All right. We don't have him right now with us, so I'll just move on to the next participant. Meanwhile, whenever he joins, we'll take his presentation. Our second presenter is Boyago Seropola, presenting a paper on the title An Integrated XAI CRISP DM Framework for Post-HOC Interpretability for Botswana's Clinical Data Mining. I request you to kindly take over with your presentation, sir. So, Seropola? I can see you in the meeting, sir. Am I audible to you? Okay. Hello, sir. We cannot hear you right now. Hello, sir. Is, is there any issues with your mic? Sapoago? So would you like to rejoin us if there is any technical glitches on your end? Hello. All right. It seems like sir is rejoining us. Let's just wait for 1 minute.
Hello?
Yes, sir. Yes. Now we
Oh, you
can
can
hear
hear
you.
me now.
Yes, sir.
Okay, let me share my screen.
Yes. Yes, please.
Okay. Is my screen visible?
Yes, sir. Right now it is visible. However, the
Okay.
presentation mode is not on.
Okay, let me put on presentation mode.
Yes. Thank you.
Okay. Okay. Uh, it is fine now, right?
Yes, sir. Perfect. Thank you.
Okay, thank you very much. Okay. Hello everyone. My name is Boako Seropola from Department of Computer Science from University of Botswana, and my co-author is Josh Anderson. I'm going to present a paper on an integrated XAI, Explainable Artificial Intelligence, CRISP DM framework for a post-hoc interpretability for Botswana's clinical data mining. Uh, so we are proposing a framework which we are integrating explainable AI with a CRISP DM framework. These are our contents of the presentation. We're going to do introduction, problem statement, literature review, proposed framework, results, and result analysis, including future work. Okay, first part is introduction. Currently, we have models, our machine learning and deep learning models are black box models. So we don't really understand what those models do behind them. So interpretability currently is the most important part where people now want to understand how those models make decisions. Currently, machine learning has been used for, yes, it is used for transforming healthcare analytics globally. And then in Botswana, they are currently using it for risk stratification and uh, the performance metrics which are mostly used like AUC and ROC or F1 score. They fail to explain how the model performed, or they don't really explain the behind logic of the model. And then, okay, hold on. Oh, sorry. So we are proposing a modified, our research objectives to propose, we are proposing a modified crispy DM framework where we want to study how it can be used in Botswana context. So our research problem is, like I said before, standard metrics such as accuracy, AUC, F1 score, they don't really explain how the machine made decision, or how machine learning or deep learning models made decisions. And then you don't know whether there's a detected model bias in the results, and then ethical inconsistency of the model. So basically, you see that when we are running both machine learning and deep learning models, you only see the results, like accuracy 90 or 80% accuracy, 80% F1 score, but you don't really understand how those model made those decisions, like I said before. So you might find that your model is biased, but it is biased and give you good results. So that's what we are trying to solve. So our literature review, the first paper examined the CRISPR model, basically for how it's been used in data science and how it can be applied to projects such as data analytics, data science, and data mining. And then a paper by Simela et al., 2025, they studied the HIV prevalence in Botswana using data from Botswana AIDS Impact Survey. So it showed how many people are living with HIV and AIDS in 2021, and then the key factors that affects those people were lower education, rural residency, and marital status. And then we also have a paper by Suhande and Wayani. They present an updated CRISPR methodology where they propose guidelines on how to use CRISPR DM model. And then from there, Ludenbeck and Lee, Landbeck and Lee, they proposed a model called SHARP, which treats features like players in a game, and it calculates how much each player contributes to uh, how much each player contributed to a game or in a game. So here, Sharp, we are going to use it to see how each feature has affected how model made decisions. And then we have Lime, which was introduced by Ribeiro. It also explains features on which features affected the model predictions, or which features really are which ones are affecting the model to make decisions. We also have the generic CRISPR DM framework. So CRISPR DM stands for Cross Industry Standard Process for Data Mining. So the first part is business understanding. Business understanding basically means understanding what your business is trying to do, and then data understanding, understand what type of data are you going to deal with when you are running your models, and then data preparation, cleaning your model, cleaning your data to make it suitable for machine learning and deep learning models, and then modeling, which machine learning models are you going to use, such as ANNs, decision trees, and others. And then evaluation. What metrics are you using to evaluate your model performance? And then from there, we have a deployment. Now, deployment is basically putting your model into real world use. So like you are seeing here, we have 6 phases. And then for ours, we are proposing a new framework uh, where we integrated Sharp and Lime, and then we have a monitoring stage instead of having a deployment stage. Also, we have a monitoring stage at the end. So what we are planning is, okay, before you you start your data mining or data science project first, you have to define your prediction target and critical constraints. And then also data understanding, you do EDA, exploratory data analysis, bias screening, and data ligages. And then for data preparation, you clean, encode, and split your data, training and testing data. And then on the modeling stage, you model your machine learning uh, training by basically you develop your machine learning model such as XGB Boost, MLP, and others. From there, you embed Sharp and Lime for to understand how your model made decisions, and then you have trust and evaluation, how you evaluate your model. Uh, is your model trustworthy? Is it your model fair, and or is your model follows the governance or policy of Data Protection Act? And then you also have deployment, where now you put your model into real world use. And then at the end, we integrated or we propose a new phase called monitoring. When now after this, you always check how if you put new data, you check whether there are changes in your model predictions and others. So what we did a case study. We used a paper from Simela et al., where we wanted to see an HIV risk stratification using Botswana clinical data, looking at Simela et al. Paper and Dorothy 2006 report. So the problem is high accuracy machine models are black box, hindering clinical trust. So like mostly in health, we need to know how, because it's a sensitive industry or a sensitive part, so we need to understand how our models made decisions. Like if it says someone has a flu, we need to know what symptoms are, which symptoms are the main ones that said or that contributed to the model saying someone has a flu. And then we going to use a Shy Crispy DM solution, which is Sharp and Lime. Then our metrics are going to be impact score, which model made more decisions like the score, and then exploratory. So here's the Sharp. Sharp is it's a tool, mostly the
I'm really sorry to interrupt, sir. However, we
yeah.
have crossed our 10-minute mark. So this is just a gentle
Oh,
reminder that you have 2 minutes
okay.
to the presentation. Thank you.
Okay, this is Sharp, and I'm not really going to go much into Sharp. And then this is Lime. So here is our data set. Where we got from the bait data set. It's free. So we have features. These are our features that we are going to use. So here we really looked at the risk factors on how based on this data set, we looked at the risk factors of a person who is uh, possible of getting HIV and AIDS. So our results are here. Like you are seeing, the green ones shows that a person is not likely to be uh, having HIV and AIDS, and the red one shows that someone is at risk of having HIV and AIDS. So this you see Lyme. So if you look at the last part, it says sexual activity before 15 means a person who had indulged in sexual activity before the age of 15, so they're at high risk of getting HIV and AIDS. So here we used two models, MLP and XGB Boost. Oh, Light GB Boost. And then this one is Sharp. It also shows the red part shows the what you call this thing the risk factor. The blue one shows that the person doesn't have risk factors. like you are say, like you see here also in MLP, it shows that a person who's at the age of 15, and then a person who's alcohol use also, they are at risk of getting HIV and AIDS. So our risk analysis, fairness and bias, a verification was done to see if features are consistent with different socio and geographical groups. And then for Sharp and Lime, it shows that below factors are sexual activity before age 15, alcohol use, and marital status. They influence the HIV/AIDS prevalences. By including monitoring phase, we want to understand the HIV prevalence in different social groups as time goes on. Like let's say maybe something was we did this in 2021. How is the new data going to change our model? And then our conclusion is see, Shy Crispy DM method provide necessary audit trail, so we can now understand how models made decisions and how the logic behind those models, and also improve the clinical faithfulness and ethical sustainability. So recommendations are machine learning models should be accountable as they are accurate. If you say it's 80% accuracy, 80% F1 score, we need to understand if they really made those decisions without being biased and being ethically considerable. And also, instead of having a good performance, we should also have ethical, clinical ethical or statistical transparency of our models. And for our future work, we want to use a shape crispy framework across different diverse domains such as finance, business, and education, and also extend the scope from Botswana or to other countries or regional or international contexts. So these are our selected references, and thank you very much. And thank you for giving me this opportunity and attention. I'm done.
Thank you so much. Now I would like to invite our session chairs for questions, if any questions are there from their end.
Kim, you want to say something?
Yeah, thank you for the presentation. I have two questions. I would
Yes, sir.
appreciate if you answer the question at a high level, not too
Okay.
technical detail like a formula. Uh, how did you evaluate whether the explanations generated by SHAP and Lime are reliable and meaningful for healthcare decision making?
Okay, thank you for the question. What we did is we looked at different papers, and we picked on which like let's say what other people had said in the previous studies, and then we compared our 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 results to those papers and to those results, and then we ran, okay, uh in this paper they mentioned that using having uh alcohol use, it affects the person's choice, and they may end up being at the risk of getting HIV AIDS. And also, yeah, that's what we mostly did.
Okay.
Mm.
Thank you. My next question is, one of the research goal is ethical inconsistency. I'm very
Yeah.
interested in ethical issue associated with AI. So,
Mm.
do you have any standard or absolute standard to check against ethical consistency? There should be some guideline or standard. Do you have that?
Mm. Oh, okay. On that one, I what I did was we looked at different social groups and geographical areas, or let's say social groups, and then we checked on if the one how features are were being I don't know how to put it, like if this feature for a person who's in a rural area, is it's the same feature in the person in a urban area, and then we see how it works across
Mm,
the group. Yeah.
mhm.
Yeah.
Okay, thank you. Thank you for the answer. I'm
Thank
done
you.
with my questions.
Yes,
Okay, thank
I
you.
have only one question.
Yeah.
That how you can decide these features, number of features, and how you reduce in the number of parameters on this.
Okay, may you come again?
Yeah, please.
Okay, I said you may you come again? I didn't hear properly.
Then how you can define the selected number of features,
Oh, okay.
right?
We okay, thank you. Thank you. Now I understand. Okay, we our like I said, our research was based on on a case study. We focused on the paper by Simel et al. We just
Okay.
used their data, and then we took what they were dealing with, because they were mostly using statistical methods, and then us, we used machine learning models, and then we just took that data as it is, and then we cleaned it, and then we made it what you call it? Just put it in load it into our model, and then we run it. Yeah.
Okay. Whether it's a real data or it's a dummy data.
No, it's a real data. It's
Okay.
a data. It was a survey data from done by Statistic Botswana,
Okay.
based in 2021. Yeah,
Okay. Okay. Okay.
it's a
Thank you.
free data.
Thank you.
You're welcome, sir.
Over from my side. Okay.
Yeah.
Thank you so much for your presentation.
Okay. Thank you.
Thank you, ma'am, sir, for your questions. Now, I would like to call upon our next presenter for this session. Our next presenter is Ana Laura Lazama Sanchez, presenting a paper on the title Deep Convolutional Neural Network for Automated Classification of Autoimmune Skin Diseases. I request you to please take over with your presentation, ma'am. Ms. Sanchez?
Yes, please. What, you know?
Yes.
Do you see my screen?
Yes, ma'am, we can see your screen. Front page of your presentation.
Well, good evening in London and good morning in Mexico. My name is Ana Laura de Sama Sanchez, and today I will present our work titled Deep Convolutional Neural Network for Autoimmune Classification of Autoimmune Skin Disease.
Your voice is low.
Yes.
Ma'am, could you come a little closer to the mic if possible? Hello, ma'am.
Okay, this research proposed a deep learning approach for the automatic classification of 5 autoimmune skin diseases using clinical image. The objective is to evaluate whether a convolutional neural network trained from scratch can assist in the diagnosis of this type of disease. I will introduce the problem and explain why autoimmune skin diseases are challenged. Then I will review related works, describe our methodology, present experimental results, and finally discuss the conclusion and future works. Autoimmune disease occur when the immune system attacks tissues of the body instead of protecting them. In dermatology, diseases mainly affect the skin and often present similar visual characteristics, making diagnosis difficult even for experienced dermatologists. Recent advances in artificial intelligence, especially convolutional neural networks or CNN, have shown excellent performance in medical images. However, few studies especially address the automatic classification of autoimmune skin diseases such as lupus, psoriasis, and lichen planus vitiligo. Previous research has explored several approaches for studying skin diseases. These include 3D tissue models, machine learning, and deep learning techniques, pharmacological studies, non-invasive medical imaging, molecular analysis, and advanced imaging technologies. Although this approach have contributed significantly to dermatology, most of them focus on general skin disease or use transfer learning. Therefore, there is still a lack of studies, especially designing for autoimmune skin disease classification using CNN trained for scratch. Our methodology begins with a dataset of dermatological images organized into five classes. The images are loaded and pre-processed by resizing them to 110 by 224 pixels and normalizing the pixel values. During training, we apply several data augmentation techniques, include random rotation, some horizontal flippings, and contrast adjustment in order to improve generalization and reduce overfitting. Finally, the process images are used to train and evaluate the convolutional neural network. Here we present the overall performance of the proposed model. The CNN achieved an overall accuracy of 70.31% with a precision of 70.88%, recall of 70.31%, and F1 score of 70.53%, and a mean AUC of 91.68%. These results indicate that the proposed model has a good ability to distinguish among the five dermatological categories. When analyzing each class, we observe that healthy skin achieve the highest F1 score of 0.82, followed by vitiligo with 0.80. Psoriasis and lichen planus obtain intermediate performance, while lupus achieved the lowest F1 score of 0.46. The confusion matrix allows us to identify where the model makes mistakes. The main confusion occurs between psoriasis and lichen planus because these diseases share similar inflammatory partners. Regarding the generalization gap, the difference between training and validation accuracy remain relatively stable, indicating only moderate overfitting, a good convergence during training. The Rioxy course demonstrates the discriminative capability of the model. All classes achieve AUC values greater than 0.87, while the average AUI reached 0.9168, indicating a strong class separability. The training and validation curves also show stable convergence despite a moderate degree of overfitting, which expected when working with relatively limited medical data sets. In conclusion, the proposed CNN training from scratch successfully classified this autoimmune skin disease using clinical image. The model achieved an accuracy of 70.31% and a May ANC of 91.68%, demonstrating good discriminative performance, healthy skin, and vitiligo, obtaining the highest classification performance, whereas lupus remaining the most challenging class. Overall, this results we suggest that the deep learning can provide valuable support for dermatological diagnosis. For future work, we plan to expand the data set used in this article by incorporating multi-center clinical image. We also intend to evaluate more advanced deep learning architectures, such as transfer learning models and vision transformer. Finally, we aim to improve probability calibration and validate the proposed model using external clinical datasets to enhance its applicability in real world, specifically in Mexico. There are some of the references that support this research. The rest are in the main document. Thank you very much for your attention.
Thank you so much for your presentation, ma'am. I would like to ask our session chairs, do we have any questions from your end?
Thank you for the presentation. Anna, could you bring up the table 3 slide?
Yes.
Slide that shows table 3.
Table 3.
Yeah. Result.
Yes, performance
Yeah.
by disease.
Right. So the model shows different performance across disease classes. And table 3 apparently shows that lupus and lichen planus classes are challenging classes, right? So do you have any plan to improve the classification accuracy for these challenging classes, such as lupus and lichen planus?
I don't understand. In this
Do
case,
you
in table,
these two classes shows a very low performance of model. And do you have any plan to improve the classification accuracy for these two classes, lupus and lichen planus?
Specifically for this course, weakest and vitiligo lupus. No, not in this moment, but maybe in future work.
Yes, so you mentioned in the presentation that more data will be needed to improve these classification performance for these two classes. So do you think adding more training data will help to improve F1 score or any other method you have in mind in the future?
In for F1 score and additional for other methods, with in this case CNN on, for example, transformers, other methods related with image.
Are you done with answering? I think she cut off.
Ma'am, she's
Ah.
there in the meeting, however. Miss Anna, ma'am, can you hear us?
Yes. Do you hear me?
Yeah. So my question was, you may just answer yes or no. Would adding more data will improve classification performance of lupus and lichen planus? Yes or no?
Yes.
Okay, thank you.
Okay. And now, which specific classifications model you have used to classify this disease?
The model is CNN convolutional neural network.
Okay, but what's the background? This is a multi-layer or a single layer?
Multi-layer.
Single layer. Okay, then have you did any comparisons with other models or other data? What the existing they have? How you can how you can say that your model is a best model?
With this data set, yes, but the future work is this model. In this model, used other data set.
How are you understand my questions? How you can say that your model is the best model?
In this moment, yes.
Okay. Okay, thank you. Thank you.
Thank you.
Thank you so much for your presentation, ma'am.
Thank you.
I would like to announce our next paper. Meanwhile, our next paper presenter is Catherine Gracia Velez, presenting a paper on the title Digital Transformation of the Public Sector in Ecuador, Reform Trajectory and Institutionalization, 2021-2025. If anybody is available from the team or ma'am is available, I request to kindly take over. All right. So, ma'am, Dr. Kim, Dr. Mishra, unfortunately, we don't have any other participants joining us right now. However, I'll just announce their papers, and we will meanwhile give them 2 to 3 minutes if anybody is joining. I'm really sorry for this experience. However, we don't have any other participants right now along
No
with us.
issue, no issue, no issue.
So sorry, sir, ma'am. So I'll just announce our next paper as well. Our next paper is by author C. Bhagat Basha, presenting a paper on the title Enhancing Blockchain Data Security with the Prime Secret RB Method. As again, nobody's available right now. If anybody is there, I do request if anybody joins in or has joined us. Meanwhile, I request you to kindly please open your mics and could please pitch in before we skip you if you join in. Next paper is by author Rory Levi's, presenting a paper on the title The Case for the Neuromorphic Sentience to Control Large-Scale Artificial Intelligence. All right. So these were all the participants for us for today. I'll just 1 second. I'll just call our. I'm really sorry for this experience, ma'am, sir. However, this is the first time we are having such an issue wherein only 2 of our participants have joined till so far. I just request for 1 minute more so that if anybody wishes to join or is joining, meanwhile, can join us. Ma'am, sir, should we proceed with closing whatever is suitable, I'll do accordingly, because unfortunately we are not able to connect to anyone of the 4 participants that we have remaining for this session.
Okay. So
Should we
should I say closing mark?
for sure, ma'am. I'll just start with the closing mark, and I'll just invite your comments along with that. I'll just close the session once. Okay, all right. So I'm really sorry again for this. Yes. Meanwhile, ma'am, if you want to, yes, you can make the closing remarks for both the presenters that we had right now. Both of you all can do that, and then we can close. Meanwhile, if anybody joins in, I'll take them. That we can do.
Okay.
I just invite your comments. Please give us the feedback.
Okay. So can I say my closing remark?
Yes, please. Yes, please.
Yeah. So thank you, the 2 presenters, for your presentations and engaging discussions. And I think what you shared are very valuable research contributions. And I appreciate your participation. And I hope you continue to enjoy the rest of the conference. Have a nice day.
Thank you, ma'am. So from your end, any feedbacks?
Yes. I think both are the presentations was very good, and I hope they will continue, and will study more on that, and they will enhance their work and will do there in the institutions. I think, and then the questions asked by the Kim was very excellent questions to the mark this. So thank you, Kim. And right, I am the one of the editor of this Word WS4. So thank you for joining with us, and thank you.
So nice to meeting everyone.
Thank you so much. I'll just put the closing remarks. Please do not exit. We have to take a snapshot as well. I'll just do the closing remarks and we can just continue with the snapshot. I sincerely thank both the authors and for their excellent presentations and contributions in this session and your participation for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of this conference. We'll be happy to have you in the 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. So kindly cooperate with the team of World S4 2026. I would like to show the token of appreciation for both our session chairs on behalf of World S4 2026 and Global Knowledge Research Foundation and partners. I'd just like to showcase our token of appreciation. This is our first token of appreciation for Dr. Kim. Thank you so much, ma'am, again, for being a part and bearing with us. Any which ways, we had only two presentations. Still, we thank you so much for your cooperation. And this is second token of appreciation for Professor Dr. Durgesh Kumar Mishra. Thank you so much, sir, for being a part. And thank you so much for all. Now, I just request, please switch on to your camera so that we can have a quick snapshot of this virtual session we just attended.
Thank you, thank you, thank you, Riddhi, and thank you, Prashi.
Thank you so much, sir.
Thank
I
you.
request Miss Anna as well as okay, sir is opened his mic. Okay, okay. Miss Anna, please kindly switch on to your camera, please, so that we can have a quick snapshot, if possible. Okay, all right. Thank you so much. Thank you.
Thank you.
Thank you all. Thank you.
Thank
Have a
you.
nice day.
Hey,
Have a
nice
nice day,
day.
ma'am. Thank you.
Bye.